Good afternoon to all of you all. Here, now we would like to see what is the maximum distance between two SHMs along a straight line. We are assuming that the SHMs have a common mean position or common center of oscillation and they are moving in a straight line. So let us say the equations of the SHM are x1 is equal to a1 cos of omega t and x2 is equal to a2 cos of omega t plus phi. Let us try to understand this term omega t. Omega is called as the angular SHM, angular frequency of the SHM. Omega is in radians per second and t is in seconds. So omega t gives the angle in radians. So omega t is angle in radians. It is called as the phase of the SHM. This phase continuously keeps on increasing because as time passes, omega t will continuously keep on increasing. So now this one single oscillation constitutes a phase of 2 pi radians. So from one extreme to other extreme it will be pi radians, that will be the phase. From one extreme to the mean position would be pi by 2 radians. So one complete oscillation is 2 pi radians. So that is how we understand phase. Here if you see the phase, there is a term phi here. Let us try to understand what this phi is. See at t equal to 0 here, cos 0 is 1, x1 is equal to a1. This particle is at the extreme position. But if you put t equal to 0 here, this particle is not at the extreme position. It would be at a2 cos phi. Put t equal to 0, you will get a2 cos phi. So this phi determines what is the initial position of the SHM and it is called as the initial phase. So phi is the initial phase. Now let us say the two SHMs are executing, the two particles are executing simple harmonic motion, and let us say at time t equals to t naught, the distance between them is maximum. Distance is maximum. So I can say the position of the first particle x1 0 would be a1 cos of omega t naught, and the position of the second particle would be x2 naught is equal to a2 cos of omega t naught plus phi. Yes, we can say this. Now we can see that x1 naught and x2 naught need not be on the same side of the mean position. If you take x1 naught, if we assume omega t naught to be acute, x1 naught will be positive. Yes, x1 naught will be positive. Now coming to x2 naught, if omega naught t naught is acute, x2 naught need not be positive because it depends on what this phi is. Supposing phi is a small acute angle. Let us take the cases. Let us say phi is a small acute angle. It is small acute. If phi is small acute, omega t naught plus x would be omega t naught plus phi would still be acute and x2 naught will be positive. So x2 naught would be positive. If phi is a large acute angle, if phi is a large acute angle, then you will have a situation where this omega t naught plus phi becomes obtuse. So the particle would be, and cos of an obtuse angle is negative, so x2 naught will be negative. Similarly, if phi is obtuse, x2 naught will again be negative. Let us try to understand this on a straight line. Supposing this is the straight line which we are showing here. This is the mean position E naught. So x1 naught, which is positive, is somewhere here. x1 naught is here. Now x2 naught, we are assuming, we wish to assume that A1 is greater than A2. A2 can also be greater than A1, but any one assumption will be valid. So A1 is greater than A2. So if A1 is greater than A2, you will find that x2 naught, which is A2 into cos omega t naught plus phi, will be less than x1 naught. What is the reason for that? You must note that cos theta is a decreasing function. As the angle increases, cos theta decreases. So cos of omega t naught plus phi will have a lesser value than cos of omega t naught. And we are saying A2 is also less than A1. So therefore A2 into cos omega t naught plus phi will be lesser than A1 cos omega t naught. So therefore we say x2 naught will be less than x1 naught. And as we said, if it is a small x2, if the small acute angle, if phi is a small acute angle, x2 naught will be positive. So we are showing it on the positive side. Whereas if it is large acute, x2 naught will be negative. It will be to the left hand side because cos of a obtuse angle is negative. Similarly, this is for small acute and this is for large acute, and if it is obtuse it will be further lesser. This is obtuse. Now this being the case, we can now see what will be Dmax, the maximum distance. The maximum distance when phi is a small acute angle, would be x1 naught minus x2 naught. Mod of x1 naught, mod we are saying the positive value of x1 naught minus the positive value of x2 naught. This would be the maximum distance when it is small acute. When it is large acute, or it is obtuse, large acute or obtuse, it would be x1 naught plus x2 naught. It would be mod of x1 naught plus mod of x2 naught. That would be the Dmax. Yes. So let us now see how we can find out what this Dmax is in terms of A1, A2 and phi. Now there are two approaches that we can follow. The first approach is the approach of calculus, and after that there is a very simpler approach which we shall talk about after we do the calculus approach. Let us say we have got the position x1 and the position x2 given by this. Now we wish to find out what is the position of 1 with respect to 2. 1 with respect to 2 is a1 cos of omega t minus a2 cos of omega t. 1 with respect to 2 is x1 minus x2. Yes? So this will be x1 minus x2 is the position of 1 with respect to 2. This position of 1 with respect to 2 we would like to maximize. So let's differentiate this. If you differentiated this, dx12 by dt would be equal to derivative of cos omega t is minus sin omega t, and there will be an omega which comes out. So there will be minus a1 omega sin omega t. This will be plus a2 omega into sine of omega t plus phi. Now for a maxima or a minima, the first derivative should be 0. So we equate this to 0. If you equate this to 0, omega goes off and you have a relation a1 sine omega t is equal to a2 sine of omega t plus phi. a1 sine omega t is equal to a2 sine omega t plus phi. From this, we wish to find out what is omega t naught. When the maxima occurs, we are saying the time has now become t naught. So I will put this as t naught. So this is the condition for the maximum distance. So we will have to find out what is omega t naught, find x1 naught, find x2 naught, apply this depending on the situation and find d max. So let us find sine omega t naught. So if we this will be sine of omega t naught. Let's open this up. This will be sine of omega t naught cos phi. Sine of a plus b is sine a cos b plus cos a sine b. So this will be cos of omega t naught sine of phi. Now sine omega t naught, let's bring it to this side. So you will have a1 minus a2 cos phi into sine omega t naught is equal to a2 cos of omega t naught. Now we would like to bring everything in terms of omega t naught. So cos of omega t naught we put it as 1 minus sine squared omega t naught into sine of phi. Okay. So let's square both sides. You will have a1 squared minus 2a1 a2 plus a2 squared cos squared phi into sine squared omega t naught is equal to a2 squared sine squared phi into 1 minus sine squared omega t naught. Bring this sine squared omega t naught to this side along with the coefficient. So you will have a1 squared minus 2a1 a2 plus a2 squared cos squared phi, that will be plus a2 squared sine squared phi sine squared omega t naught is equal to a2 squared sine squared phi. So we shall get what is from this what is sine squared omega t naught. Before we simplify this, I would like to write this result here in this corner because we are going to use it later. So phi small acute we have d max as x1 0 minus mod of x1 0 minus x2 mod of x2 0. If it is large, acute or obtuse, we have the distance as x1 0 plus x2 0. We will retain that. Now let's see what we. So we have basically sine squared omega t naught. We have sine squared omega t naught is equal to a2 squared sine squared phi, a2 squared sine squared phi divided by a1 squared minus 2 a1 a2. This a2 squared would be common here. This will be, this is when we expand, when you square this, you will have a1 a2 cos phi. Here also this is 2 a1 a2 cos phi. Yes, the 2ab term would be 2a1 into a2 cos phi. So a2 cos phi. So 2a1 a2 cos phi, and a2 squared is common here. So cos squared theta plus sin squared theta is 1. Cos squared phi plus sin squared phi is 1. So you will have plus a2 squared. That is sin squared omega t naught. Now let us find what is x1 naught. X1 naught would be a1 sine of omega t naught, because the equation is x1 is equal to a1 sine omega t. So x1 naught at omega t naught we are finding out. So sine omega, I'm sorry, is not sine omega t naught, it is cos. The defining equation we are taking it as cos of omega t naught. So we can now write this as a1 into square root of 1 minus sine squared omega t naught. So if you simplify this, you will get a1 into square root of 1 minus, substitute this would be a2 squared sine squared phi by a1 squared minus 2a1 a2 cos phi plus a2 squared. So if you took the LCM, see what you get. You will get a1 root of a1 squared minus 2a1 a2 cos phi plus a2 squared minus a2 squared sin squared phi divided by a1 squared minus 2a1 a2 cos phi plus a2 squared. Now if you remove a2 squared common here, you will have 1 minus sin squared phi, which is cos squared phi. So you will have this as a1 into root of a1 squared minus 2a1 a2 cos phi plus a2 squared cos squared phi by a1 squared minus 2a1 a2 cos phi plus a2 squared. So this will be a perfect square, the numerator, that will be a1 square root of a1 minus a2 cos phi the whole square divided by a1 squared minus 2a1 a2 cos phi plus a2 squared. So we can now write x1 0 x1 0 we can now write as a1 into a1 minus a2 cos theta, cos phi, not theta, cos phi, divided by square root of a1 squared minus 2 a1 a2 cos phi plus a2 squared. Now we want the modulus value of this, the absolute value of this. So with the denominator, we will take it as the positive square root of this. The numerator, let's check the numerator. If you check the numerator, we said a1 is greater than a2, and therefore a1 will also be greater than a2 cos phi, because a2 cos phi will be less than a2. So therefore this quantity is positive and phi is acute. It will also be positive when phi is obtuse, because when phi is obtuse, cos phi will be negative, this quantity will become positive, the overall quantity will be positive. Therefore I can say mod of x1 naught would be a1 into this for all values of phi, whether small acute, large acute or obtuse, this will be the value of x1 naught. Let us now find the value of x2 naught. x2 naught was a2 cos of omega t naught plus phi. Yeah. So this we can write it as a2 square root of 1 minus sine squared omega t naught plus phi. Now we had the relation a1 sine omega t equal to a2 when we differentiated and equated the distance to 0, when you differentiate not the distance, when we differentiated the position of 1 with respect to 2, x1 2 with respect to t and equated to 0, we got this relation a1 sine omega t is equal to a2 sine of omega t plus phi. So therefore I can now say sine of omega t naught plus phi is 1 minus a1 squared by a2 squared into sine squared omega t naught. Now again we will substitute sine squared omega t naught here. So if you did that, you will get a2 square root of 1 minus a1 squared by a2 squared into a2 squared sine squared phi naught divided by a1 squared minus 2a1 a2 cos phi plus a2 squared. Yes. So you have a2 squared cancelling. So if you compare this expression and this expression, the denominator is the same. In the numerator you had a2 squared sine squared phi. Here you have a1 squared sine squared phi, not phi, not a1 squared sine squared phi. So if you simplify this, what are you going to get? Let's see. We would expect the answer to be a2 into a2 minus a1 cos phi with the same denominator. Simplifying it in the same way is going to result in that answer. So let's directly write it. You can work it out and verify it if you like, but I am going to directly write x1 2 x2 0, and I'm going to write x2 0 is equal to a2, simplifying this, a2 into a2 minus a1 cos phi divided by a1 squared square root of a1 squared plus a2 squared minus 2a1 a2 into cos phi. Now this quantity, we want to take the mod of this. So we will take the modulus of the denominator, the positive value. Now for the numerator, there can be several cases. What are the cases? First case is that supposing phi is a small acute angle. If phi is a small acute angle, cos phi will be a large number. Yes, cos phi will be a large number. So if cos phi is large, a1 cos phi will be large. So the one which is being subtracted is large. So therefore a1 cos phi will be greater than a2. So therefore for small acute, we will have mod of x2 naught, that is the positive value of this, will be a2 into a1 cos phi minus a2 by root of a1 squared plus a2 squared minus 2a1 a2 cos phi. Whereas if phi is a large acute angle, or if phi is a large acute angle, cos phi will be a small value because cos theta is a decreasing function. So a1 cos phi will be small and a2 will be greater than a1 cos phi. So if it is large acute, x2 naught would be a2 into a2 minus a1 cos phi by root of a1 squared plus a2 squared minus 2 1 a2 cos phi. If it is obtuse, well, this quantity is going to be positive. So if it is large angle or large acute or obtuse, well, this whole thing will be positive and we will write it in the same way. There is also a special case where a2 minus a1 cos theta is equal to 0. So when a2 minus a1 cos theta cos phi is 0, you have a case where cos phi is equal to a2 by a1. This is the special case where cos phi is a certain definite angle given by the ratio a2 by a1. Note that a2 is less than a1, so this quantity is less than 1 as it should be. So when you say small acute, phi is less than cos inverse of a2 by a1. And when you say large acute or obtuse, phi is greater than cos inverse of a2 by a1. Yes, and phi equal to cos inverse a2 by a1 is a special case. Now let us determine the distances. Let us get the distances. I am going to erase these portions to get the distances. We have got x1, mod of x1 by x2 is this, and so we have got, let's find for small acute. For small acute, you have x1 naught, it is this minus this. So it's going to be a1 into a1 minus a2 cos phi by root of a1 squared minus 2a1 a2 cos phi plus a2 squared minus this quantity for small acute. That is minus A2 into A1 cos phi minus A2 by root of A1 squared minus 2A1 A2 cos phi plus A2 squared. So if you simplify this, the numerator you are going to get A1 squared, that will be a plus A2 squared plus A2 squared. This will be minus A1 A2 cos phi and minus A1 A2 cos phi. So you will get minus 2A1 A2 cos phi, and the denominator is going to be root of A1 squared plus A2 squared minus A2 A1 A2 cos phi. So this is basically the numerator and denominator are same except the square root sign. So this would be root of A1 squared plus A2 squared minus 2A1 A2 cos phi. That would be the maximum distance when it is acute. When it is obtuse, what are you going to do? You are going to add this large acute or obtuse, you are going to add this and this. So if you add that, if you added these two, you will get A1 into A1 minus A2 cos phi by root of A1 squared plus A2 squared minus 2A1 A2 cos phi plus, there is a plus sign here, if I put x2 naught, you will get A2 into A2 minus A1 cos phi by root of A1 squared plus A2 squared minus 2A1 A2 cos phi. If you simplify this, you are going to get A1 squared and A2 squared, and there will be a minus 2A1 A2 cos phi. So you will basically, if you simplify this, you are going to get the same result, square root of A1 squared plus A2 squared minus 2A1 A2 cos of phi. That will be the distance. The special case, when cos phi is A2 by A1, we can get that. The special case, when cos phi is A2 by A1, d max would be equal to square root of A1 squared plus A2 squared minus 2A1 A2. Instead of cos phi, I am going to put A2 by A1. So A1 cancels. You get minus 2A squared here. A squared minus 2A squared is minus A2 squared. A2 squared minus 2A2 squared is minus A2 squared. So this will be A1 squared minus A2 squared. That will be d max. This is again, this is d max for small acute, d max whether when it is large acute and obtuse, the result is the same, and d max when cos phi is A2 by A1 is A1 squared minus A2 squared. Now let us see the other approach. The other approach is much simpler, it is not so tedious. See, the SHM can be treated as a projection of a circular motion on the diameter of a circle, of the circle. So let us apply that idea. So I will take x1 is equal to a cos omega t, the first SHM. So if I take x1 is equal to a1 cos omega t, What I shall do is I shall draw a circle of radius A and take a particle which is rotating in the anti-clockwise sense at an angular velocity of omega radians per second. The radius of this is A1, as I said. The radius is A1. And let us say the particle is at here on the x-axis at t equal to 0. At some instant t, it is here. So the angle it will have turned is omega t. This will be omega t. Angular velocity into time gives the angle. Now, if you project this on the horizontal axis, you can project it on any diameter, but as a special case, we are projecting it on the horizontal axis. If I draw a perpendicular here and this is 90, this distance would be x1 because this hypotenuse is a1. So x1 would be a1 cos of omega t.